Hello, Eric Magidson here, CIS instructor at Central Oregon Community College. This is lecture for Lesson 8, Managing and Monitoring Windows 7 Performance for CIS279W7 Windows 7 Configuration course. We're going to take a look at the PowerPoint and also go through some aspects of Windows 7 performance as it pertains to the local computer that I'm using. So let's get started. Got some objectives that we'll cover. Since we're going to cover those objectives, we'll just continue on. So updating Windows 7, I find this funny that Microsoft says current operating systems are always a work in progress, constantly being updated to correct errors, enhance performance and features. Well, the fact is, in computing today, features and functionality are changing daily. I remember when I had a Windows XP machine that didn't even support USB. It wasn't a detailed or common feature at the time, and here came a service pack that added USB, that kind of thing. But certainly we would hope that operating systems would come as secure as possible, but we know with all the hacking going on, hackers are always looking for new vulnerabilities that may not have been discovered at the time that the operating system was produced. So one of the primary tasks of a desktop support technician is keeping systems updated, keeping software updated, and we're going to look today on how we can do that for a retail machine, a single one-off, as well as how we might do that more efficiently within a network infrastructure, so using deployment updates. So types of updates, of course, hot fixes where we have an immediate fix that needs to be done. It may not have been completely tested, but it's important enough to get out there. Security updates, again, sealing or patching those buffer overruns that may cause vulnerabilities in the system, leaving memory open for virus writers to write their applications or their viruses into those memory buffer overruns, etc. Cumulative updates and roll-ups, and then, of course, service packs, which are essentially all of the above, put into over a period of time. We get a service pack. We may have already installed a lot of the updates, but we install the service pack as well, as it may include additional updates that have yet to be released, or just make sure that we've gotten all of the updates since the last service pack release. Update categories, important updates, things that should be installed, recommended updates. Again, recommended. Optional things like updated language packs, additional that we may not use on our computers. And then device drivers. Today it's pretty common to get updated device drivers within the Windows operating system or within Windows Update services. Certainly we want to go out and check with our devices, make sure that we have the right device driver. Remember that in the case of Dell on some older machines, Dell had specific drivers for their Dell machines, and so do other manufacturers. So we want to make sure that the device driver we're installing is supported on our particular system. So applying Windows Update. Well, there's the Windows Update, which allows us to install updates to a local computer. Here, I'm bringing up Windows Update here. So you can see currently I've got one important update that's available and 3 optional updates. Let's go look at the optional ones. So here's a Dell bus controller, a micro input, and then an update to Windows 7. The important update is a Windows Live Essential. Of course, I can read about the KB article and see what it's affecting and why they're suggesting it's an important update. From here, while we're here, let's talk about updating retail computers. In the configuration, or how we update computers, we have many options. If you notice here, I've set mine to install all updates automatically. Now, of course, this means that all the updates are going to be installed automatically, so if I happen to get an update that affects my computer in a negative manner, I'm going to have to do some troubleshooting. But from a retail standpoint, consumers tend to get bogged down with the fact that they start up the computer and here it says Windows wants to update, and they continue to say, not now, not now, not now. They don't install the updates and wonder why their computer gets riddled with viruses, where a lot of times these updates would keep those buffer overruns from happening and viruses couldn't get installed in the first place. We can see we have some other options here. We can download updates, but let me choose whether to install them, so consequently that gives the user more control. check for updates, but let me choose whether to download and install them. So again, here it's downloading them for me. I choose when to install. Here I got to tell it to download and install. And of course, as we go down this list, fewer and fewer users are going to do all these tasks. So, I'm of the opinion that if we're talking about a one-off consumer computer, let it do the updates. Very, very, very seldom do you have a problem with it. But certainly in a network environment, we don't want to do that. We want to use some other features and functionalities to do the updates, because of course, if we install one bad update to one consumer computer, it's affecting that one computer. If we install one bad update that might interfere with some additional software we're running on our network that majority of users are using, or it's a bad update that somehow interferes with our system, users can't log in, and suddenly we have a big issue. Can you imagine a bad update on the COCC campus getting installed to all the machines and then finding out there's a problem? So the way we get around that is we use what's called Windows Server Update Services. And this is where, instead of having the machine go out to the internet and download the updates and install the updates from the Windows Update Services, it basically does it through a computer that we've configured into our network. Now, another thing that this does, obviously, is it reduces the bandwidth that we're using to update systems. Basically, that one server, and we're going to take a little bit more detailed look at this, becomes the update server for every computer in our organization. So we're downloading the update one time and then distributing it to all the computers. Now, another benefit of this is the fact that as we distribute them, we're deciding when to distribute the updates. So consequently, we have the opportunity to maybe install the updates on one or two computers in each department, make sure they work, make sure they haven't affected any software, and then do the update a day later or so. Now, sometimes there's serious updates or those hot fixes that need to be installed automatically. And again, you need to determine the risk versus reward of when and how long you take to install those. Up and above the Server Update Services, WSUS is the System Center Configuration Manager. This is for high-end or very, very large networks, and it's essentially WSUS on steroids. Also allows us to do things like install updates for other software packages besides Microsoft's, etc. So here is the Windows Update Client. Again, we looked at this briefly, so we can do the configuration about how, does it download and install automatically? Does it just download and let us determine when to install? Does it prompt us to not only download but also install? Or, of course, never install. And, of course, if we pick never, that's what we would do if we're going to use a WSUS. We would configure it within group policy to not go out to the Windows Update Services anymore, but instead use a WSUS server in our organization. So configuring the client, we looked at that. Important update options, so install update automatically, as we talked about. Download the updates, let me choose whether to install them. Update, check for updates. Now remember, this may not be an option if you've installed an operating system on a hard drive with limited space, because of course every update takes up more space on the hard drive, just something to keep in mind. But today, hard drives are so large at 600 gigabytes that it's okay to install those updates automatically in comparison to not installing those updates. So moving on here. Configuring Windows Update using group policy. So here's Windows Update. Now, of course, with group policy, if we do this back on a domain controller in group policy for all the machines in our location, we're not having to do this for each and every machine. Let me see if I can find some group policy here. Here we go. So here's group policy. Here's the Windows Update portion. Here are all the configurations for Windows Update that we can set. Stuff like, allow automatic updates, immediate installation, turn on software notifications, allow non-administrators. And of course, if you're wondering or needing more detail, we can actually just click on this and get more detail, more help as to what the feature's going to do. Okay, we can enable it, disable it, we can make comments, etc. What is it supported on? So of course we can always go in and get more information without actually configuring. Group policy, of course, is the preferred method of doing a lot of things within a network environment because of the fact that we are configuring that for each computer on our network. And then, of course, we can group computers based on configurations. We want to, in my opinion, reduce the amount or make it next to impossible to do anything at the domain level, and then increase functionality for computers and users as we go through the groups or the organizational units. So triggering an update, you all, I'm sure, have seen the update notification come up in the bottom of your screen. We can then click and view what the updates are, what should be installed, look at optional updates, make that determination if we want to install those as well. Keep in mind that if we're not using a functionality on our computer, then why install the updates? So Windows Server Update Services downloads updates to from the Microsoft Update website, just like a consumer computer would do. But in this case, we're downloading them one time. We're storing them for administrator evaluation. So again, it's going to go get all of those updates. Even if we're not going to install them, it's going to go out and get them. We can then determine what gets deployed to our computers or our servers on our network. So computers on the network download updates from the WSUS server using the reconfigured Windows Update client. So consequently, we're going to configure the client to point towards the update server versus going out to the web. Again, reducing all the bandwidth, reducing time to update. And of course, we're going to know that the computer got updated. So we're going to know that if it was an update that secured a vulnerability in our client operating systems, we're going to know that it got done. So here's a little diagram of an architecture. This is the Windows Update server that normally each client would hit. In this case, we reconfigure it. The WSUS server inside our network gets the updates from the update server. And of course, then we determine how and when those get deployed to our clients. Excuse me. Deploying WSUS is pretty easy. We need to do it on a Windows Server 2008 R2 machine. Yes, WSUS was available before that and can be installed on a previous machine. WSUS software is a free download from Microsoft. Again, we need to download it. It's web-based, so we're going to need to install the Internet Information Services role on our server since it's web-based. It requires a database. This can either be a SQL Server database for larger networks or just a Windows internal database. They got SQL Server Lite type aspects that we can use for free as well. So once we deploy it, configuring WSUS clients cannot be done with the Windows Update program. It must be done through group policy. So we would go into group policy and point those client machines towards the WSUS server as its new update server. So moving on to monitoring performance. So for a computer to perform well, all of its components must be efficient. We know that. We know that when we received the Windows Vista operating system, one of the big things was the video card. We needed 128 meg of dedicated video in order to run the Arrow functionality. So a lot of the old Windows XP machines required hardware updates or new computers altogether. So Vista and Windows 7 include tools to enable you to locate poorly performing bottlenecks, the event viewer, the performance and information tools. We're going to take a look at some of these. So the event viewer, the primary function is to record information as it happens on the computer so that we sort of have a single place to go to look at events that may have caused failures or other things on the computer. Let me show you the event viewer on my computer here. We can see that here we have in the past 7 days, we have one critical event. We can go and look at that event. So there was a kernel power system. That happened to be on the 15th when I purposely powered off my computer the wrong way, and I'll show you that in a minute. Certain events, and then of course we can go in, double click, get more information on the event, and troubleshoot the computer from these. So we've got event viewer, we've got Windows logs such as application logs, anything that's going on with the computer, information. Here's an error, an application hung. We can get more information. It looks like windward or windward hung. It stopped interacting for some reason. So consequently, a lot of times these errors tend to be things that we just shut down the application, restart it, the application comes back fine. But if we have continuous errors, we can go in and get those and look at those. So here is the security log. We can see that there was, a successful audit success, which means the login was successful at 2:18 at 2:17 p.m. Setup logs for things like software that we set up. A lot of times vendors for software will install setup logs, making sure things work correctly during setup, etc. System logs, so things required for the system. This happens to be the service control manager, when it was logged, etc. Notice all of these are information-based things. Then we get the warnings. These are the things we want to look at. And then, of course, the critical, if there's any criticals in there, we would want to make sure to address those immediately. So we can sort, again, by date, time. We can sort by source and move on. So the overview or summary, we kind of took a look at this, understanding, that there's application logs applying to applications, security system, etc. Windows logs, so systems logs, things that are happening in the Windows operating system that may need to be addressed. Performance information tools. So this is where we can go in and actually look at the performance of a computer. And I'll bring up, for example, a couple of those for us to look at. Let me quickly bring up. One of the first things I always like to do is right here, the Windows Experience Index. So I right-clicked on Computer, went to Properties, gets me into the system. Here's where I can see, what my processor is, how much memory, etc. And what I can do is run this Windows Experience Index, and it will give a calculated score to the processor, memory, what my graphics functionality is, gaming graphics, if I'm using that, primary hard drive space and transfer rate, and then, of course, come up with a general, average number based on the sub-scores. So I can see how well my computer is sort of performing given the hardware that's in it. So, would upgrades help improve the performance? I can drill down into that, conserve system resources, etc. So here's that index run on a poor computer. It looks like graphics, desktop performance for Windows Aero is 1. So certainly in this case, if the computer was upgradable, we could put in an updated video card to improve the performance of running Windows Aero. And then, of course, if the graphics aren't going to work for Aero, it's certainly not going to work for 3D business things and gaming graphics. As we know with programs like AutoCAD or drafting-based programs, the more graphics we can throw at it, the better. So using Performance Monitor console, so in here we can go ahead and configure things like Performance Monitor to see how things run. Oops, that's not the one I wanted. That's the one I wanted. Here's the Performance Monitor. I'm going to quickly run. As you can see, we get a quick system summary. This is always updating as I run the computer, so we can look at network interface, we can look at the physical drive space, what its idle time is, foresee other drives that I have installed, etc. The processor information, so interrupt times. And again, if you're wondering what these times are, you can always search the web to see what an acceptable threshold is. Here in the Performance Monitor, you can see I have a processor time. I'm going to go ahead and right-click down here and add another counter. I'm going to come up here to Memory. And I'm going to add available megabytes. I'll add that counter as well. Say OK. And as you can see, available meg, I might want to change the color. Silly that it would come under a different color, but I can come in here and change it, change the color, etc. Change that to like a green. There we go. And as we can see right now, it's right up here at the top, 100. So, available megs, I'm in good shape. One of the things is In this case, we did megabytes and percentage. We might want to actually pick a percentage so it comes in here. So the percent of available memory time. So I could come in, add counters, go to memory, and pick the percentage memory versus size. That way, of course, they would come in, because all this is basically telling me is I have over 100 meg. So of course I do. But there's the performance monitor. As you can see, as we pick this and add counters, we just have a ton of counters. One of the nice things if you're working on a network is you can actually run perfmon from back on your workstation or another workstation. If it's connected to the network, you can pick other computers to monitor the performance of. So it's not like we have to go to the local computer and run this. Remember, as we're running Performance Monitor, it's always querying the processor, querying the memory, querying the paging files, querying all that stuff, which means actually the computer is running even less efficiently as we're doing the Performance Monitor. So you definitely don't want to leave a Performance Monitor running on a computer all the time. Adding counters, we looked at how easy that was. Right click, add counters. Again, you get descriptions of counters, so you can go through those counters in detail. Other views, histograms work well, besides the live preview. So limit the number of counters again. Make sure they're within the same range. So if we're dealing with megabytes, have all the counters deal in megabytes. If we're dealing in percentages, deal in percentages, that kind of thing. Choose counter with available, like we said, comparable values. The reliability monitor gives us a little graphic. Here's the reliability monitor on my computer. We can see that we had some information events happen here on the 8th, again on the 12th, on the 13th, 14th, 15th. Here's one that I did on purpose. On the 15th, you can see that Windows was not shut down properly. So I can go and view the technical details as to what happened. Simply, it's going to tell me it was shut down. But if I wanted to, I could go and look at the errors within the event log to see what might coincide with that, etc. And then, of course, if we start seeing these down here, we know the computer's not running real reliable, and we need to do something about that to increase the productivity of our users. So again, other things that we can do, we can manage through Task Manager, Resource Manager, Project Manager, Systems Configuration Tools. I'm sure you've all hit the Control-Alt-Delete and gone into Task Manager. We can see CPU usage. If we have a dual core, we're going to see 2 graphs for that, quad 4 graphs. Memory that's being used right then in real time, always good. Processes. So this is one place that if we come in and we notice that the CPU is really being used, but we don't see much running, or we see a weird processor service running, that may be a virus. Using Process Explorer, so we can come in and actually look and drill down at what processes are taking, how much CPU usage, how much resources, etc. Configuration tools. So in order to troubleshoot a computer, you might want to customize its configuration through msconfig. We can do a normal startup, loads all the drivers, devices. Diagnostic startup loads basic devices and services only. We can do selective startup. So this is the idea that if we want to troubleshoot or figuring out what might be failing or what might be using a lot of resources during startup, we can do that as well. Managing services, going into services, we can see what services are running. A lot of times errors occur on computers when services stop running, okay? As well as we may be running services we don't need to use on our computer. So this is where we could gain some efficiency by looking at what the service is, determining if we need to be running it on our computer or can we shut it down. Remember, all these services that are running, if we're not using them, they create a potential vulnerability for someone to use to hack into the system if there's a vulnerability in the service or whatever the case may be, buffer overruns, etc. So remember now, though, that Microsoft has taken the backwards route in that a service is only started when you start using a service or functionality that requires it. So we can go in and configure virtual memory, configuring power settings. So of course, if we're on a laptop, power it down sooner than later because we're on battery or connected to the wall, etc. Configuring hard drive caching, So write caching is when the device stores data in temporary memory until the slower devices can catch up. Of course, caching can be a performance issue for a computer. We start seeing more caching, larger caching on processors now. You know, it used to be 1 meg cache, and now 6 to 8 megs of cache on a processor. Ready Boost, which is essentially utilizing the storage on a USB as system memory when it's plugged in. So we can configure Ready Boost to use spare space on our USB drive to increase the performance of a computer. And then that's it. So these are the general skills summary of the areas we covered. So now you'll go and you'll do the lab and get a better hands-on understanding of the material presented during this lecture. Have a great day, and we'll talk to you soon.